What's the great thing about block size? Well, block size is repetitive. And since it's repetitive, it's going to be easy for you to remember the possible sizes of each block. There's only so many sizes you can have. Take a look at the chart we have here. It says block size. You can have a value of 1, 128, 64, 32, 16, 8, 4, 2, and 1. Those are the only possible values you can have. And they repeat 128, 64, 32, 16, 8, 4, 2, 1. And then they repeat again for every single octet. So if you're a /8, your block size is 1. But if you're a /16, your block size is 1. If you're a /24, your block size is 1. What that means in this case is that you're counting by 1 in the first octet. You're counting by 1 in the second octet here. You're counting by 1 in the third octet here. But now let's do some subnetting. Let's say we're a /11. If we're a /11, we're counting by 32 in the second octet, right? But if we go down to a /19, we're also counting by 32. But instead of being in the second octet, now we are in the third octet. Let's take it a step further, and let's go down to our /27 here. We go down to our /27, notice we're counting by 32 in the fourth octet. So if you look down at the bottom here, you'll see that our very last bit is in the 32nd decimal position. If we go back up to our /19, it's also in the 32nd decimal position. We go up to our /11. Again, 32nd decimal position. So remember that block size is all about that subnet mask. Where is the very last one? I'm going to pick /22. Where is the very last one? The very last one is in the third octet here. And what is the decimal equivalent of that bit position? In this case, it is 128, 64, 32, 16, 8, 4. So it's 4. And we can see that right there. Let's pick another one to practice with. Let's go with a /28. So if we're a /28, where is the very last one? It is in the fourth octet. And what is that bit position? 128, 64, 32, 16. We're counting by 16 in the fourth octet. Let's go up to a number 12 here, /12. Where is our final one? Our final one's in the second octet. And as a result of that, we're counting by 16 in the second octet. So really, really great chart here to help you solidify your understanding of block size, but also so that way there you can see exactly what is the block size going to be based on the various subnet masks and how it just simply repeats. So a 9, a 17, and a 25, same values, 128. 14, 22, and 30, same values, a block size of 4.